Yes.
Excellent.
Sorry about that.
No problem. We are not responsible for all technical failures. I'd like to welcome you all to the second meeting of the year for the Bitcoin Cash developers. We're going to go through a number of items on the agenda. I believe you've all had a chance to see the agenda. We will start with an introduction from each of you, and time permitting, and I'm pretty sure there will be, after we've gone through the agenda, we will take questions from the audience as long as they're related to the topics at hand, and give the panelists an opportunity to answer those questions. So without any further ado, I'd like to start by, my top left-hand corner is Mark Lundeberg. Mark, could you introduce yourself, please?
Hi, I'm Mark Lundeberg. I'm just sort of a generic Bitcoin Cash developer, I guess. Recently, I released something called OpenSwap, you might have heard of. I also worked on Simple Ledger protocol. But now I'd like to help with some protocol development.
Great, thank you, Mark. Jason B. Cox, please.
Hi, I'm Jason, Bitcoin ABC developer. Been contributing to Bitcoin ABC for a little over a year now.
Thank you, Jason. Antony Zegers.
Yeah, as I was saying, I'm Antony Zegers. I'm known as Mangarian online, and I just try to help out with Bitcoin Cash stuff in general and Bitcoin ABC mostly.
Okay, that's great. Thank you. Longwen, could you introduce yourself, please?
Yeah, hi everyone. I'm kind of a new guy in the community, and I have background of cryptography, and I was involved in two projects before in Bitmain. One is trying to re-implement Bitcoin Cash protocol with Go programming language, and the other project is the wormhole project, kind of a second layer smart contract solution for Bitcoin Cash. That's all.
Thank you, Longwen. Appreciate that. Amaury, are you able to introduce yourself? Or have I caught you in the middle of Byte? I'll come back to you in a second. Chris, Pacia.
Hey, Chris from OpenBazaar, and also contribute to the BCHD full node, Bitcoin Cash full node.
Thank you, Chris. Matias.
Hi, Matias from BitPay. I mainly work on BitPay wallets, and that's it.
All right. Thank you, Matias. Dagur.
Yeah, hi, I'm Dagur. I'm a developer. I mostly contributed to Bitcoin XT, but I also contribute to a lot of other projects.
Thank you, Dagur. Good to have you here. Andrea Suisani.
Hi, everybody. I'm Andrea Suisani, Bitcoin developer.
Thank you, Andrea. And Nodar.
Hey, I'm Nodar. I'm working on Bcash full node implementation in JavaScript.
Okay, that's great. Let me just see if there's anybody here that we've missed. Anybody? Oh, Amaury. Sorry.
Yeah, so I'm Amaury Séchet. I'm the lead developer of Bitcoin ABC.
Okay, thank you, sir. Is there anybody else that was missed in the introductions? No? All right, I posted the agenda items on the chat. So we're going to start off with a discussion of the upgrade timeline, and I think maybe we'll ask Jason to give us an overview of the timeline.
Sure. So I don't think we discussed it in detail in the last meeting, if I remember correctly. But in general, we try to make sure that upgrades are available to the public way in advance of a hard fork. The last two hard forks have been roughly 2 to 3 months, so we're shooting for 3 months again this time around. That means we need to start getting our implementation wrapped up here in the next month. It's not a lot of time, so we want to make sure that, we plan it out here, decide who's going to be the owner of various items going into the hard fork, and deciding what can make it and what can't.
Okay. Anyone else like to speak to the upgrade timeline? Any questions about the upgrade timeline from any of the panelists? Moving on to item number 2 on the agenda, Schnorr signatures for CHECKSIG and CHECKDATASIG. Who would like to introduce the topic and discuss it?
I can take care of that this time.
Thank you, Mark.
Yeah, so Schnorr signatures, basically the idea is that right now we use ECDSA algorithm to sign transactions. And that's what we use to spend any coin, where you can say that the coin is owned by somebody. And the idea is to also allow Schnorr signatures on any coin where you could do ECDSA previously. And the advantage of Schnorr, it's a little bit faster to verify. So in the long term for scaling, this will be helpful. But also I'm actually personally interested because there are some interesting benefits for multi-signatures. For doing privacy, you get better privacy because you can have multi-signatures that look like regular transactions, regular single participant transactions. And there are also some malleability benefits. So this could help if you want to do some sort of, smart contracts with off-chain transactions, that sort of thing. It could be helpful.
Anyone else have any questions or like to comment on the Schnorr signatures as presented by Mark?
I have a small question. The plan is still to not implement Schnorr in multisig, right?
Right. Yeah. So the reason is that the way check multisig works right now, it's not really compatible with the batch validation with this speed up in performance that we want to have. So probably what's going to happen in a later fork is that we'll create a second mode of execution for ops check multisig that is compatible with batch verification. And this would be something that you could, again, apply to any existing coins. So that would be nice, but we just haven't figured out the exact details of how that works.
Thanks.
So I have a question. So you want to include Schnorr without getting the main benefit, which is multisig?
Well, yeah, so there's actually two ways. With Schnorr, there's going to be two ways to do multi-signatures. So one is the usual way, which we would have to add later, as I just said. But then there's a second way, which is doing signature aggregations. So you could have a bunch of parties who all participate in producing a single signature. And on the blockchain, that'll just look like a regular pay-to-public key hash output. So this is one of the advantages to Schnorr. You can do it with ECDSA, but with Schnorr, it's much easier, basically.
Is there any benefit then to keeping opcheck multisig around?
I would say so, actually. So opcheck multisig, what you can do is you can just have one party sign a transaction, and then they would just pass it on to the next party. So if you have a 2 of 3 multisig, it's just one round of communication, basically, or even a half round. And with Schnorr, unfortunately, with these aggregated signatures, you need to have an interactive protocol between all the parties. So they first have to talk to each other once to establish some initial settings to make the signature, and then they have to proceed to actually produce the individual signatures. And for security reasons, apparently it's necessary even a third round. So this definitely has to happen like online, interactive, that sort of thing. So yeah, good for smart contracts. But yeah.
Any further discussion on Schnorr signatures?
Yeah, in the interim, we there were some proposals made to the changes proposed to the spec. The E value is going to be mod n, right, instead of having the bound on 0 and n. Is that I guess kind of finalized or agreed upon that part of the spec?
Yeah. So what Chris is referring to is in the cryptography. At some point you compute this integer E, and the question is whether it should be restricted so that there are certain hash values that are not allowed, or you should just take a modulo so that any value is allowed. And the way we've gone is to use the modulo in the end. So that's finalized, I think. Yeah.
Any further questions or comments?
So regarding its review, this one seems to be one of the most threatened items for the next hard fork. There was a lot of concern, I think, in the last meeting and even before the last meeting, whether or not we're going to get enough reviewers. Primarily, cryptographers and that sort of thing. We need people to come in and take a very close look at the Schnorr implementation. I wanted to know what your guys' opinion is on that, and how much time you think you can personally commit to reviewing that section of code before it goes live.
Yeah, so I've reviewed it myself, but if anybody else wants to additionally review that, that would be great.
Yeah, I mean, can you guys hear me now? I put on a new headphone.
Yeah, we're good.
Okay, good. Yeah, I was going to just comment on that also. There's also two parts, like there's the code and there's the specification. So yeah, I mean, I guess I would just encourage anyone watching this who has any interest at all to try to have a look at the spec. There's a bunch of design decisions in there that, I mean, have been thought about and they seem to make sense, but people should have a look at that. As many people as possible to make sure that nothing was overlooked. So now's the time, I guess.
Yeah, I mean, I've reviewed it in the course of re-implementing it in Go, but I don't know if my review of the actual cryptography and stuff is worth a whole lot personally. But
yeah,
but other than that, it seemed good to me.
I mean, I'm also thinking about things like just the way it's implemented in CHECKSIG, like whether to have a byte a type byte at the beginning of the signature or not. Like, I think Mark kind of decided that you don't really need that, and it's nicer not to have it. But that's something that maybe other people should think about a bit. Stuff like that. You know what I mean?
Yeah, if we change this is something that should be decided quite soon, I think.
Yeah.
Yeah.
So I mean, if it seems really solid in the next couple of weeks, then maybe it can go into the upgrade. But I mean, it can also be delayed potentially if it seems like there's some question about anything.
Yeah, if it has to be delayed, that's not great, but it's fine also,
Is 2 weeks from today a good drop dead deadline for this then?
It's aggressive.
Well, I mean, could you express it in a different way as to what the best plan is for go, no go?
Well, one, I would like to see everyone sign off on the spec. Two, I would like to see a bunch of people sign off on the implementation. I would like to see a lot of tests written for the implementation. And then we have to see some code for activation. And so given the current progress, the rate of progress, I see skipping it as being likely. But I could see it being finished in time for the next hard fork, for example.
Not this one coming up.
Right.
You mean upgrade, of course.
Sure.
Any further comments on Schnorr signatures and inclusion, non-inclusion in the next upgrade?
No, just a small comment that I can try to implement that on Bitcore, our JavaScript library, but it would take at least 2 weeks for, I can start working on that in 2 weeks. That's all.
Is that too late? Jason?
Well, it's not so much that it's too late. It's just, Bitcoin ABC will be going on this schedule of making sure all the changes for the hard fork are done about 3 months in advance. That doesn't really have any bearing on other node implementations, although we would encourage them to follow the same schedule. But in that implementation period that Bitcore is going to have, kind of like how Chris has essentially been reviewing it by re-implementing it, I would hope that your team is taking a really close look at the security implications of implementing it, and hopefully if you write a bunch of test cases, which you should be, then you'd be sharing them with the community at large, and we'd be pooling our resources in that regard.
Yeah. That's the main objective, to give it a look while re-implementing.
That's great. Thank you for the clarity on that. Anything further on Schnorr signatures? Hearing none, we'll move on to the item number 3, which is BIP 62 items, the Null Dummy. Who would like to speak to this? It almost feels like we need a crash test dummy to speak up.
I mean, I guess I would just ask the question in general to people, like for these BIP 62 items. I'm not sure. I think I thought Chris maybe mentioned something about malleability. Like, is this something that has value to try to get done? I'm not even sure, like, if there's a huge motivation to get these last 2 things done. I'm just curious about that.
I don't, since we've done all the others, I think we should try to get them done unless there's a reason not to, unless it poses a problem. Because
I mean, I kind of agree. I mean, there are certain things that you can't do with the malleability, right? So I mean, not that I'm like chomping at the bit to write this payment channel code, but I have some like partial payment channel code in Go that would need, malleability to be fixed. So, I mean, it's not, I don't know, it's not like a feature like it would be absolutely soul crushing if it wasn't fixed, and we didn't have that feature, but there are things that are interesting that you can do with it. So, and I mean, I kind of agree with Dagur, like we're 95% of the way there.
Yeah, actually, so one reason I'm interested in Schnorr is in combination with the malleability fixes from BIP 62. You can do some really interesting things, like you can have a payment channel where the final thing that ends up on the blockchain is just like, it looks like a regular pay to public key hash transaction. So that would be great from a privacy point of view. And if you only have the Schnorr or you only have the BIP 62, then you can still do some things, but it's a little bit more awkward. So yeah, so I think the combination is actually something really great. And I hope we have both in the long term, even if it doesn't happen in this hard fork.
Okay, any further discussion on item number 3, BIP 62? And also item number 4, BIP 62 with the minimal data push. Not sure if you need to discuss that separately, so.
Well, does anyone have any reason not to add those fixes? Okay.
What did you say, Dagur? I didn't hear you.
Does anyone know any problems with adding these malleability fixes? Is there a reason not to continue with them?
There is one thing that should be clarified about the Null Dummy, which is whether or not it applies to all script execution or also, or just the script pub key part. So in particular, there's the script sig part of the transaction and the script pub key, let's say, or the redeem script in the case of a Pacia public key hash. So does the null dummy apply to only the script sig or to all scripts that are being executed? And for anyone in the audience who's wondering, it shouldn't affect things like op returns, so you can still use non-minimal pushes in op returns. That's no problem.
Oh, you're talking about the data push, right, Mark?
Yeah. Yeah.
Okay. Yeah.
So what it is basically it requires you to use the minimal form of pushing data. Right now, there's like 4 different ways you can push the same thing onto the stack, let's say.
I know there was the concern about bricking coins. You know, if it applied, I can't think of any case in which the script pub key where we would have to validate there, right? Because if it's in a P2SH address, it's going to be validated the hash anyway, right?
Yeah.
Or
for malleability reasons, it's only necessary to apply it to the script sig.
Yeah, and applying it to the script sig isn't going to brick any coins, right?
Correct. Yeah.
Yeah. So I mean that seems like the way to go.
Yeah.
Any further comment on item number 3? No. Item number 4.
I mean, I guess I just was gonna say, like, it kind of seems like, given the timelines, like, I don't know what it takes to make this happen. Like, is it super easy, or should we? Is there a plan? Like, if people want to, it seems kind of like people want to do this.
Yeah, we need an owner for this, because if there is no owner that's gonna make it happen, we can all day long, but nothing is gonna happen.
Yeah.
We have an owner wanting to step up.
Yeah, I can work on that.
I knew it was going to be you, Dagur. I was watching your picture, waiting for you. Okay, good. Everybody happy with that? Will that also be the case with item number 4, minimal data push? Are they included together?
I think we should get all the fixes in big 62.
All right. And Jason, just in terms of the timeline, how long does Dagur have to pull this all together?
3-4 weeks.
Okay.
I'm definitely willing to help review code and whatnot and point him in the right direction if he needs it, but I won't be able to contribute a lot of my personal coding time to that, unfortunately.
Anybody else willing to help Dagur on this?
Yeah, something I cannot really make it happen by myself, but I'm willing to help and provide feedback about that, no problem.
Thank you for stepping up, Amaury. Anyone else who has not spoken would like to offer some assistance on this? Okay. Moving on to item number 5 then, the clean stack possible fix. Who was taking this one on?
Someone just want to reiterate the issue. Just restate it.
Sure. I think I can try to describe it. Basically, again, it really kind of relates to these 62 items. One of them implemented last hard fork was the clean stack, which basically means at the end of execution, you have to have only one item left on the stack. This turned out to be a problem for I'm losing my words. When you send coins to
SegWit.
Yeah, sorry, look for that word. SegWit. That's SegWit addresses that are implemented as P2SH. So basically, if people send by accident their coins to a P2SH SegWit address, it becomes unspendable. I saw a little bit of information about this because the problem is that as soon as you try to spend the SegWit coins, it reveals the script that produces the hash, which then on Bitcoin Cash, anyone can use that to spend the coins because the SegWit rules aren't enforced on Bitcoin Cash. So the issue is that if someone spends the coins on Bitcoin, then that reveals enough information for anyone to then go and spend the coins on Bitcoin Cash from that address. So basically, we're kind of in a situation where if these become spendable, they'll probably be stolen by anyone who wants to try to steal them. So yeah, it's a bit, basically there's a few ways that can be used to fix this. You could either reverse the clean stack rule, or you could make like just an exception for this particular case, saying if it fits this pattern of the SegWit P2SH, then we could say, well, we're gonna let that be spendable. So I don't know. It's a bit of a murky situation, and it's not totally clear what the best way forward is. I hope I described it well enough. So that's my description of the problem. I don't really know what the solution is.
I mean, as much as you don't want to be like just tell people to go screw off if they sent coins to the wrong address. I don't know if it's worth us forking to essentially bail people out, and I'm not sure how many people this even applies to.
So we've been doing some data gathering on that end, and it's still in progress. It's not clear how many people are still affected. It sounds like some people were affected immediately after, Bitcoin Cash came into existence, but it's not entirely clear to me if it's still affecting a lot of people to this day. And if it's not the case, then I don't really see the maintenance cost being worth it.
Just the detail of this. So on Bitcoin Core, they introduced these Betch32 addresses, and I believe those are distinct from these P2SH coin losing addresses. And you can't send, from your Electron cache, you can't send to one of these Betch32 addresses. So there's none of that confusion there. So I think moving forward, it's going to become less and less and less common. So yeah, there's that.
I mean, yeah, like from my perspective, I think you really, really don't want to like brick coins. So I think it's worth looking into. I just think at this stage it's not obvious what to do. So I think it just needs maybe more research and more work on it.
Yeah, so on one end, you don't want to brick coins. I would be for having some kind of exception for SegWit coins, but on the other end, we never supported SegWit on BCH. And we cannot guarantee that any kind of weird idea that someone wants to do on the blockchain that look like Bitcoin Cash is gonna, work well if you do it on the Bitcoin Cash chain. This is very much something we cannot guarantee.
Yeah. For what it's worth, I agree with Chris. It seems to me it doesn't make the effort to make this. I never heard of someone losing coins because of that, and I deal with many customers every day. So at least for me, it doesn't make any sense to do this.
Just out of curiosity, Matias, what is your customer base?
It's hard to tell, but we host almost 3 million wallets.
Yeah. Okay.
Yeah, I think just to clarify, so I think there were some areas where people did get affected more frequently, and that was, let's say you had an exchange where you had one of these P2SH SegWit addresses for deposits. That would definitely, some users would get confused and they would send their Bitcoin Cash to those addresses. So that was, I think, one thing that was happening. And another thing that could happen is, for example, if you have a tip jar on your website and you put a a SegWit address there, then people might think, oh, I can send Bitcoin Cash to that guy. And again, that would just, those coins would be accidentally lost, basically. Or, you know, before the November fork, they were stolen by some anonymous miners quite frequently, actually. So yeah, it's not an ideal situation because of that.
So is there an action item to come out of this?
I think there's only an action item if someone is really keen on becoming an owner for this.
Okay.
I don't see, it doesn't seem to me like anyone in this room is really keen on fixing this in the immediate term. So I guess I would like to motion to, you know, officially strike it from this hard fork. And if it comes out later that there's data to support that it's worth fixing, we can fix it for the next one.
Okay. Is there general agreement in this room about that?
I would still be for doing it, so I would not strike it, but in the absence of owner, it's not going to happen like any other item. So right now we should make it clear that there is no owner for that one, and we need an owner fairly quick. Or like, to me, it's very much like a market-driven thing, right? Like, to me, if nobody is willing to step up and do the work to make it happen, it's probably that nobody cares enough for it to be worth doing. So even though my personal opinion is that it's worth doing, if that doesn't happen, then that would just prove that my personal opinion doesn't reflect the opinion of the community.
Thank you, Amaury.
Okay, given that, let's give it a couple weeks. You know, we can shoot out a couple messages and see if someone is willing to take it. But barring that, I don't. It doesn't sound to me like anyone in this room is going to be committing their time to fixing it.
When this video is released, I think there'll be an invitation for people to participate if they feel the need. I
think the biggest issue with this fix, the reversal fix, is that, you know, if we fix this and we put in all the effort, then at the fork time, some rogue miner will come in and he will steal all the coins, and then it was just wasted effort.
Probably true.
All right, we have a trademarked 2 weeks on this one, so we'll leave it open for the time being.
Yeah, I guess just to reiterate, yeah, like anyone watching this video, if they should be encouraged to work on this if they care about it.
Okay. All right, thank you, Antony. We'll move on to item number 6, the 100 byte transaction size rule. It's carried over from last meeting.
Yeah, in the last meeting I volunteered to take care of this item. So today I publish a PR on the Bitcoin Cash spec repository, which is shared with the website. And well, basically I propose to relax the constraint. Specification is pretty straightforward. I won't even call it specification, by the way. And I'm willing to develop to push PR both for Bitcoin and Bitcoin.
Andrea, can I ask you to move a little closer to your mic? I'm not sure everyone's catching what you're saying.
It's better now?
Yes.
Yeah. So, like I said, if everybody is on board with the proposed solution or something along that lines, that basically is a relaxing of the constraint, something like now all the transactions that is lower than 100 byte in size are marked as invalid. What I have proposed in the specification PR that I published this morning is to mark as invalid only the only transaction that is precisely 64 byte in size. I'm not married to this solution. For me, also having a constraint that said that everything higher than 64 is okay will be a good thing to have. So, like I said, I'm willing to code the solution for both ABC and BU. So please have a look at the pull request that I pushed to the Bitcoin Cash repo, specification repo. This is it.
Can you link that for us?
I was just going to ask the same. Could you put a link
Sorry?
up? You put a link up.
Yeah. Just a sec. I'm going to find out where it is.
That's great. Thank you, Andrea.
You're welcome.
Nice.
A little historical point on this, actually. So I did some research around the time the last hard fork was being discussed, and there are actually 30,000 transactions in the blockchain that are, I think, 63 or 62 bytes. And that's pretty much the smallest transaction that you can make. And basically what they were some miner who was kindly recovering a bunch of UTXOs that were created that were sent to an empty script, I think it was, or an empty script pub key. So there are times when you can go under 64 bytes, but it's a weird special case, basically.
Thanks, Mark.
I've just pasted the PR link on the chat, Zoom chat.
In the Zoom chat, just going to have a quick look. For some reason I don't see it. Ah, yes. Okay, we've got it. Thank you. I'll make sure that's in the show notes underneath the video when it goes out as well. And everyone has access to that as well. Yes, it's gone out to the attendees in this meeting as well. So, great. Any further discussion on item number 6? Hearing none? Oh.
No, I wanted to do a remark about it. Not that I'm especially against or for it. To me, it seems like a very like it's not a very important item, because as Mark mentioned, there are actually very few transactions that are concerned by this, and it's not even blocking for those transactions because they could put an up return or something. So I would like to avoid that becoming like a big topic, or like, you know, if it requires any kind of effort that is substantial from anyone, I would just drop it.
Could you define this kind of effort? I mean, like, yeah, we need to change the code and review the change, I guess, and I mean, tests and stuff like that. Is this too much?
No, if you're willing to do it, then
yeah,
that's great, right? But
okay, I will.
Yeah.
That's great. Thank you again, Andrea, for stepping up to this. Anything further on item number 6? Hearing none, we'll move on to item number 7, more basic opcodes, invert, mul, LSHIFT, and RSHIFT. Who is speaking to this morning, or today? Sorry.
Yeah, last time I have I volunteered to search for someone to take care of this item. I have talked to the EU developers, namely Andrew Stone, and he is interested in improving the opcode situation. But like Amaury said in the last meeting, the actual situation with the opcode, basically the arithmetic that they are implementing is not worth the effort in Andrew's opinion to have it re-enabled. Something that he is fond to put effort on is having opcodes with complement to arithmetic and stuff like that, rather than re-enabling old opcodes with the old structure. So I thought that it was interesting in working on the re-enable of basic opcodes, but this is not the case. It's more interesting in increasing the utility of opcodes, introducing another kind of opcode that deal with situation in a better way.
Anyone have any comments on that?
Yeah, that doesn't seem like something that could be done in a month.
Indeed, this is something that of longer timeline. This is something that needs to be designed and carefully, and at least, even if someone is going to start now, it's not even sure that we're going to have it in the next fork, in my opinion. Network upgrade, sorry.
Thank you, Andrea. Any comment on that? All right, any further comments on item number 7, more basic opcodes?
Well, this just sounds like the other one. I guess without an owner, it's probably not going to move forward then, right?
That's right.
Okay.
I guess I'd just throw in my 2 cents. Is like I wonder if someone was interested, even if to just do one of them, say is invert useful on its own, for example? I don't know, like that one seems less controversial, but I guess it's just an idea for someone out there. But yeah, I kind of agree with everyone else.
Okay. We're good. So anybody who's interested in taking on some leadership role with regard to opcodes can contact people involved here. Okay. Moving on to item number 8 then, which is our final item on the agenda, which is increasing default unconfirmed transaction chain limits. Jason, you want to speak to that first?
Yeah, so there's, this is actually not a consensus item. My understanding is that BU doesn't even have this limit imposed. Andrea, you can confirm.
Yeah, well, the default that we currently have is the same on ABC, but the fact that we don't have children pay for parent means that we will be less impacted in case of increasing the limit. In fact, during the GigaNet test block initiative, we increased such parameters by 10x by default.
Okay, yeah, so what he was referring to was there's a performance complication on ABC where child pays for parent explodes exponentially and becomes very, very slow for long chains of transactions. And we would like to lift this, and one of the possible ways of doing that is by removing child pays for parent. But currently there's no owner for it. The nice thing is that with it not being a consensus item, ABC can do this at any time. So if someone wants to be an owner on this and take that, then
yes and no. We should not do this at any time, because the problem is you need to have various node software to have consistent settings, because each settings that is different essentially weakens the security of zeroconf.
Oh, right. You'd mentioned this earlier. It was like a flag day. You want to do a flag day upgrade.
Yeah, that's preferable, even though this is not a fork in the sense that people are not going to be forked off the network if they don't change the setting. But you need to have the majority of the participants, at least of the miners, to change the setting at the same time, so that we don't weaken zeroconf. Otherwise, you can do a chain of 25 transactions, and then the next one is going to be accepted by some people and rejected by others. And every time you have one of those, you can exploit it to try to have a zeroconf success. And the more discrepancy there are, and the more opportunity you have, the more possibility you have to create a successful zeroconf.
Right.
And every time we have some configuration discrepancy that way, we just weaken zeroconf.
Yeah, and that the children pay for power, and also the longer chain you set in your mempool, the higher is the vectors attack surface for someone to craft difficult to traverse chain of unconfirmed transaction. So in any case, we need to measure this kind of performance, this kind of possible worst scenario in determining how much, how many more transactions we admit to how, or better, how do you choose a new threshold? It's 40 enough? Is 50 too much? It goes above children pay parent. You need also to check for other code path in the code base.
Now, if I remember correctly, you mentioned someone at BU might be interested in running these statistics, like high SIGOP transactions that are chained together for arbitrary chains.
Yeah, I thought that Andrew did something, but I asked him and then he didn't, since it was busy to solve other bottlenecks that came in before reaching the point where too long chain of unconfirmed transaction were actually a problem. Actually, we don't even hit that bottleneck during the test, so he didn't go further to measure such cases.
Okay, so for all the data scientists out there, I would like to point out that if all they want to do is measure the performance of this, if you could generate really high SIGOPs, transactions, chain them together at various lengths exceeding 25, we may be able to bump the unconfirmed transaction chain limit a little bit beyond 25 without making substantial code changes, as long as we have that data in order to make that decision. And then to bump it significantly, like 100 or beyond, then we will have to have someone come in and clean up child pays per parent, or at least drastically improve the performance of it. So there's a couple options there, and if someone wants to take that, that would be very, very beneficial to Bitcoin Cash, I think.
Any further comments on this? Okay, hearing none. I believe that we've reached the end of the agenda. Were there any other items that you people would like to bring forward at this point?
I have a question regarding, if you go back to the old opcodes.
Yes.
I think there are actually two problems involved here. One is actually bringing back the old opcodes. The other one is removing a quirk in the script language, which is disabled opcodes, which behaves differently than unknown opcodes. So maybe that is something to fix by itself, to remove the concept of disabled, just call them unknown.
So disabled opcode actually behaves differently than unknown opcodes, because if you have, so the difference is if you have an unknown opcode in a code path that is not executed, then it's okay. But if you have a disabled opcode, even if it's not executed, it's not okay. Actually, I think that the behavior of disabled opcode is probably preferable, because this is one of the things we ended up running into when activating CHECKDATASIG, is that there is a bunch of CHECKDATASIG in the blockchain, but a bunch of opcodes that are in branch of script that are not executed that contain CHECKDATASIG. And so it affects the calculation of SIGOPs and various other stuff like that. So we tried banning unknown opcodes is probably the best option.
Sorry, do you mean you prefer disabled opcodes or unknown opcodes?
Yeah, I think disabled opcodes are easier to deal with, right? Because we don't end up with the possibility to have a bunch of garbage in the blockchain in unexecuted paths of scripts, which make it then difficult to upgrade the script language. Because say you wanted to add an opcode that is similar to if and end if, for instance, then they work by pair. Suddenly, if you have some branch of the code that is not executed and you have like one of those subcode and there is not the corresponding one, then in the case of if and if, for instance, the way it's interpreted, that wouldn't work. So we couldn't use one of the unknown opcode to implement something similar to op if and if. Fortunately, we don't need to because those opcode exist, but there is like a class of things that we cannot do with the opcode that are unknown right now. But there is no limitation on what we can do with disabled one because they are disabled and they cannot be in the blockchain in any way.
Is this clear?
So in that case, then maybe if we reintroduce the old opcodes, we should use a different code prefix. So it's not re-enabling that this was disabled one, but adding it as an unknown. If that makes sense.
Yes, it does. I haven't thought about it too much, to be honest.
That's a discussion for another time.
Okay. Any further discussion on any other items that you would like to bring forward before we throw it open for questions from the audience? I do have a question come in. It's just someone has said, I have a question. So I'll give you just a second. The question is, would you consider dropping Cpsp?
John pays for
Yes. So Cpsp, let's explain what it is to begin with, or it's not going to be clear. Cpsp is child pay for parents. So what it is that if you make a transaction and that transaction doesn't pay enough of a fee to be accepted in the blockchain, someone can make a second transaction that spend from it that pay a fee that is a bit higher, such as the combined fee on the two transactions is enough. And if that is the case, then both transactions are accepted in the blockchain. Whereas without Cpsp, you would have the first transaction that gets rejected because the fee is not high enough, and then the second transaction arrives that pay a higher fee and would be rejected as well because it has a parent transaction that is rejected. There is a fair bit of demand for Cpsp from some actors, notably people that receive payments, because they need to be able to receive a payment and make sure the transaction goes through even if the person that makes the payment doesn't pay enough of a fee. So there is an interest at that level, but so it's probably not a good idea to remove it, but what can be done is limiting the depth at which Cpsp happens. So for instance, you can have a transaction only pay for its immediate parent. Right now, what's happening is that every time you have a transaction, the whole graph of transaction that is in the mempool needs to be processed to update all the aggregate fee of those transactions and all their parents, which is a costly operation. And this is why chaining transaction is a bit expensive. But we could do that not for the whole graph, but just for the immediate parents. And that would provide most of the benefit of Cpsp without having the drawbacks of making chain transaction in the mempool very expensive. So that would be, I think, a good compromise.
Okay, thank you, Amaury. Anyone else like to add to the question about dropping Cpsp?
I don't think we have it at all in BCHD. It was never implemented.
Not even in BU.
Not in BU as well. Is that what you said, Andrea?
Yeah, like we've definitely considered dropping it. There's also a consideration where you limit the depth to only like 1 or 2 transactions so that it doesn't impact performance for long chains. That's also a possibility.
Just an aside on this point, is there anything else besides Cpsp that impacts how long you can make unconfirmed chains? Is that the only thing, or are there some other mempool management codes that also have problems in this area?
There are a few other stuff, but I don't think the other one are as user-facing as Cpsp is. So there are cut paths when reorgs happen, for instance, that are quite costly if you have a lot of chain transaction in the mempool. There is the get block template generation that can get pretty expensive if you have long chains of transaction. But the get block template gets expensive mostly because of side effects of CPFP. So I think we can get this one sorted out if we sort out CPFP. And for the reorgs and stuff like that, we probably can do various stuff, like reorging the mempool asynchronously or something like that. So yeah, there are options. I think CPFP is really the stuff that is gonna impact user that needs to be changed.
Yeah, if I remember correctly, Jonathan Tumim did some data gathering on this, and I believe the number was 70 to 80% of the running time for get block template was child pays for parent related. So that just shows you like how much of a performance improvement we can make there.
Okay. We do have another question come in from the same person. What do you estimate would be the development effort in limiting CPFP to depth 1? Would you consider PRs doing this change?
We would absolutely consider PR doing this change. This is something we want to do. The development, I mean, I'm not quite sure how big the development effort is. The first step wouldn't be too difficult. The first step would be to write a few tests that test the behavior, the CPFP behavior that we want to keep. So immediate first span, like one parent. So if we can have tests for this kind of stuff, then we can do the other change by being sure that we don't break anything that we want to keep. And that would be an easy step, and that would be a very valuable step toward getting a solution to that problem.
Thank you, Amaury. We got a thumbs up from the person asking the question, so thank you. We're going to wind up this meeting, and I'd like to thank you all for attending. Just, can I get a quick show of hands from the people that are here? Did this meeting satisfy some of the needs of the development community for Bitcoin Cash? Okay. So we're getting basically thumbs up. I've got a smile out of Amaury, so that's good. All right. So thank you very much for attending today, and look forward to presenting this video for the rest of the people that couldn't make it today. And thank you all very much for attending.